Lesson 20, I will use models to add two fractions with related units. So far we've talked about adding and subtracting fractions, and every time we added and subtracted fractions, we had like units. For example, we've been adding fractions that looked like this. We've said, okay, well, what is 1/3 plus 2/3? Well, that equals 3/3 or 1/2. These are like units. Today we're going to see how we can add fractions that have related units. For example, we may add 1/3 plus 2/6. These can be made into common units, but I'm going to have to show you how. But today these are the kinds of fractions that we're going to add. Fractions that do not have common units or common denominators. All right, so in your math journal, we're just going to do a little bit in your math journal today, but I want you to go ahead and write today's date, lesson 20, adding fractions with unlike denominators. So that's kind of what I just showed you. When you add fractions that the denominators are not the same, that's called adding fractions with unlike denominators or unlike units. All right, so let's think about this for a minute. Please don't copy all of this in your math journal. I'll tell you what I want you to write, but I want you to think about this for a minute. If you took a banana and you add it to an orange, what would you get? Well, it's kind of a crazy question, isn't it? Well, what do bananas and oranges have in common? They're both what? They're both fruit. So what is one banana plus one orange? Well, together they make two pieces of fruit. Okay? We had to rename. We could not add a banana and an orange. We had to say that, okay, well, they're both fruit. So we didn't say that that's two banana oranges. We didn't say it's two banana plus oranges. We said it's two pieces of fruit. This is the same strategy that we're going to use when we are renaming units and fractions. When I try to add 1/3 plus 1/2, I can't say that is 2 third halves. Doesn't work like that. We have to rename the units. So that's what we're going to be doing today. So I hope that you didn't write any of this in your journal. I just wanted you to listen to that part. All right, now let's take a look at these two fractions. We have 1/3 plus 1/6. Now we want to be able to decompose one of these to be able to make like units. Well, if I take sixes and I break them down into smaller parts, are they going to become thirds? No. What happens when you take sixes and you break them down? You get a number that's bigger than a 6. Actually, I need to start with the thirds, right? I'm going to take the thirds and I'm going to decompose them into sixes using a tape diagram. So I want you to write this in your math journal. I want you to start by writing 1/3 plus 1/6, and then I want you to draw these two tape diagrams. The first tape diagram, you can see we drew 1/3, and I want you to shade 1 out of 3, and then you can see these dotted lines show where you decomposed them. If you don't make these dotted lines, it's going to look just like sixes. Okay, we decomposed these. So we took 1/3, and instead of it being 1 out of 1, 2, 3, it ended up being 1, 2 out of 1, 2, 3, 4, 5, 6. And then we're going to add that to 1 out of 6. So now I have 2 6s plus 1 6. How many 6s is that altogether? Well, it is 3 6s. So what is 1/3 plus 1/6? It's actually 3 6s. So see how that completely changed this? Because 1 plus 1 is 2, and 2 doesn't even end up being the denominator. So you have to rename this fraction so that you can have like units. And that's what we're going to practice doing today in our problem set. So let's go ahead and get out our problem set. I want you to go ahead and write your name at the top, please. And then let's read the directions. Use a tape diagram to represent each addend. Okay, each fraction is considered the addend because we add them together to get the sum. Decompose one of the tape diagrams to make like units, then write the complete number sentence. Part A is partially completed. So you can see, first of all, here's 1/4. I can tell because they had 1 out of 4, and then I can see where they decomposed it. 1, 2, 3, 4. I'm going to actually make this a little bit bigger so that we can see it better. All right, so you can see this is just like your problem set, but you can see this was the original fourths. And then they decomposed them. So they took the force and decomposed them into eighths. They did not take the eighths and decompose them into fourths because you couldn't do that. So now instead of 1 out of 4, I have 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8. Now I have 2 eighths, and here's my 1/8. So 2 eighths plus 1/8 equals 3 eighths. All right, so let's do the same thing to B. All right, so we've got 1/4 plus 1/2. So I'm going to go ahead and start by drawing 2 tape diagrams. And you're going to want to make these small enough that you can do them side by side, but you still want to be able to make sure that you can clearly count the number of boxes. So first of all, can I decompose twelfths into fourths? Of course not, but I can decompose fourths into twelfths, right? So let's start by doing this. Here's my fourths. So now I have 1 out of 4, and I'm going to go ahead and shade my fourth. I'm going to use my highlighter so that when I decompose these, you can still see it. All right, now, I'm going to take each of these fourths and make it into a 12. So if I have 4 parts and I want 12 parts, well, because 4 times 3 equals 12, that tells me I have to divide each of these 4s into 3 parts. So I'm going to use my dotted line so you can tell that I'm decomposing. So now instead of 1 out of 4, I have 3 out of 12. And over here I'm just going to make these 12s by going 1. Here's my fourths, and I'm going to divide them into thirds. 1, 2, 1, 2, 1, 2, 1, 2. And I'm going to shade 1. All right, now I have 1/12. So instead of 1/4 plus 1/12, I have 3/12 plus 1/12, which equals 4/12. All right, let's take a look at C. Okay, so we're going to do the same thing. So I'm going to use my rectangle tool here and go ahead and make my 2 tape diagrams. Now let's think about this for a minute. Can I take 6s and decompose them into thirds? No, it doesn't work that way, right? So I'm going to go ahead and I'm going to divide this into thirds, and then I'm going to divide the thirds in half so that I can have my 6s. All right, so this is my 2 6s. I'm going to come back and shade those. All right, and then I'm going to take my thirds. Here's 1, 2, 3, so I'm going to go ahead and shade 1/3. And I'm going to decompose these thirds into 6s like this. So now my third has become 2 6s. So I have 2 6s plus 2 6s equals 4 6s. All right, so let's take 1/2 plus 3/8. So here is my first tape diagram and my second tape diagram. So let's start with a half here. All right, so I'm going to divide this one in half. I'm going to divide this one into eighths. So here's my fourths, and here's my eighths. This time I'm going to go ahead and just divide them up as they are, and then go ahead and decide how I'm going to decompose these. So here's my half, and then here's my 3/8. So there's nothing I can do to these eighths. I can't decompose them to make a half, but I can decompose the halves to make eighths, right? I can divide this into 4 parts. Now they're fourths. Oops, I was supposed to make those dotted lines, okay? Now I'm going to make these into eighths. So I've got 4/8 and 3/8. 4/8 plus 3/8 equals 7/8. All right, why don't you take a minute to try to do E by yourself? All right, so hopefully you try to do E by yourself at least part of the way, and you should have drawn 2 tape diagrams like this. Doesn't matter what order you did this in. One of my tape diagrams, and I'm going to divide it into fifths like this. 1, 2, 3, 4 lines makes 1, 2, 3, 4, 5 parts. Now I'm going to take these fifths and divide them in half, so then now I have tenths. And then I'm going to take this one and divide this one into fifths. So I've got 1, 2, 3, 4. I'm going to come back and shade. All right, so now I've got 3 tenths and I've got 3 fifths. So I want to have common units. So I'm going to decompose my fifths into tenths like this. So now I have 3 tenths. And over here I have 1, 2, 3, 4, 5, 6 tenths. So 3 tenths plus 6 tenths equals 9 tenths. All right, so try F all by yourself. Pause the video, see if you can do it by yourself. If you get stuck, you can always press play. See how much you can do all by yourself. Okay, so hopefully you got most or all of this one done all by yourself. I'm going to go ahead and start on my tape diagrams here. And I have 2/3, so I'm going to start by dividing this one into 3 parts. Ooh, that doesn't look right, does it? Into 3 parts. And then I'm going to take this one and divide this one into 9 parts, like this. So there's my thirds, and then if I take each third and divide it into 3 parts, then I will have 9 parts. Okay, now I'm going to come back and shade. So I've got 2/3, I'm going to shade 2 out of 3, and I have 2/9, I'm going to shade 2 out of 9. All right, so I can't do anything to these 9ths, but I can come over here to these thirds, and I can decompose these into 9ths, and then I will have common units. Okay, so these 2/3 have now become 1, 2, 3, 4, 5, 6 ninths, and these 2/9 are still 2/9. So I've got 6 ninths plus 2/9 equals 8 ninths. All right, on to the back. Now you're going to notice that we have a different set of directions here. This, first of all, it says estimate to determine if the sum is between 0 and 1 or 1 and 2. Draw a number line to model the addition, then write a complete number sentence. Part A has been completed for you. So when it says estimate, I have to think to myself, if I have a half and I have a fourth, am I going to have more than 1 whole? And the answer is no, I'm going to have less than 1 whole. So I can make my number line between 0 and 1. And then you can see that they took this half and they changed it into common units by making it 2/4, and then they added it to 3/4, okay? All right, so let's see if we can do this. So I have a half and I have 4 tenths. Is this going to be greater or less than 1? Well, 4 tenths is less than half because I know 5 tenths is half. So I know that my answer is going to be less than 1. So I'm going to make my number line between 0 and 1. 0 and 1. Okay? Now I can't turn tenths into halves. So let's think about this for a minute, okay? This is half. All right, and then I'm going to take the rest of this number line and divide it into 10 parts. So I'm going to start by dividing all of this in, I'm going to divide each of these halves into 5 parts like this. So I've got 1, 2, 3, 4 lines, 1, 2, 3, 4 lines. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So I've got 1, 2, 3, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 10 tenths, okay? So we're starting right here with 1/2. How many tenths would be in a half? So if I went 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, okay? So I've got 5 tenths here, or 1/2, and I'm going to add 4 tenths like this. So I'm starting at 0, and here is a half. So I'm going to say plus 1/2, and then I'm going to plus 1, 2, 3, oops, I need to go one more. And then I'm going to, okay, so I start with plus 1/2, and then I'm going to add 4 tenths. So 1, 2, 3, 4 tenths. And that ends me up at 9 tenths. So I've got 1/2 or 5/10 plus 4/10 equals 9/10. All right, let's try C. Okay, so now I have my number line. I can't label it yet because I have to estimate first. So I've got 1/2, and then I've got 6/10. Well, 6/10 is greater than 1/2. So if I have something that's more than 1/2 plus another 1/2, then I know that this is going to be greater than 1. So I'm going to have to do this from 0 to 2. Okay, and I'm going to put my 1 right here in the middle. All right, so I've got to divide these into tenths. So I'm going to take it, I'm going to divide each of these into 10 parts. I'm going to start by dividing in half and then divide each half into 5 parts. So 1, 2, 3, 4. 1, 2, 3, 4. Then I'm going to divide this one in half, and then 1, 2, 3, 4. 1, 2, 3, 4. Now each of these are tenths. Okay, so I'm going to start by counting over 6/10. So I've got 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So I do this. So here's 6/10 plus 6/10. Now if I'm going to add 1/2, how many tenths are in 1/2? That would be 5/10, right? So I've got 1, 2, 3, 4, 5/10. So now I have plus 5/10, and where do I end up? I end up right here, which is 1 1/10 or 11/10. So I've got 6/10 plus 5/10 equals 11/10, which is the same as 10/10 plus 1/10, which is 1 1/10. All right, so now let's take a look at 2/3 and 3/6. Well, 2/3 is more than 1/2, and 3/6 is exactly 1/2. So my number line is going to have to go from 0 to 2. I'm actually going to make it a little bit longer because this one actually got a little small for me. All right, so I've got 0 and 2, and then I'm going to have 1 in the middle. So I'm going to start by dividing this into 6 parts because that's my greatest number on the bottom. So I'm going to divide these into 6s. So I'm going to start by dividing into thirds like this, and I'm going to divide each third into half. So this whole has been divided into 6 parts, and I'm going to do the same thing over here. Divide this into thirds, and then divide this into 6 parts. All right, so how many 6s are in 2/3? So let's think about that for a minute. Here's my thirds right here. I'm going to actually use a different color here so you can see. So here's my thirds. Okay, so here's 1/3, here's 2/3. So let's think about how many 6s that would be. 1 6, 2 6, 3 6, 4 6s. Okay, so I'm going to start right here by just writing 4 6s up here. So I'm going to add 2/3, and then I'm going to count over 3 6s. 1, 2, 3. And that puts me right here at 1 1/6 or 7 6s. So 4 6 plus 3 6s equals 7 6s. So I can separate this out and say this is my whole, and this is what's left over. So 7 6s is 1 1/6. All right, so let's take a look at E. So I've got 3/4 plus 6/8. Well, 3/4 is greater than half. 6/8 is greater than half, so I'm definitely going to have to make my number line from 0 to 2. So again, make your number line nice and long so that it doesn't have to get too small. All right, so this is 0, this is 2, and I'm going to put 1 in the middle, and I'm going to divide this into my greatest part, which is 8. So I'm going to divide it in half, and I'm going to divide each half into fourths, and I'm going to divide each fourth into 8 parts. So now I have 1, 2, 3, 4, 5, 6, 7, 8. So we'll do that again. Divide it in half, and then divide my halves into fourths, and then divide your fourths into halves. All right, so I'm going to start by adding 3/4. So let's go back and find those fourths. So this is a fourth, this is a fourth, and this is a fourth. Here's my fourths. You can see I have 1, 2, 3, 4 parts. 1, 2, 3, 4 parts. So how many eighths are there in 3/4? So if this is 3/4, how many eighths is that? 1, 2, 3, 4, 5, 6 eighths. So 3/4 is the same thing as 6 eighths. So let's go ahead and add 3/4. and I'm going to add 6 eighths. So 1, 2, 3, 4, 5, 6. So this is where I'm going to end up. I'm going to kind of do this one backwards. Plus 6 eighths, and that puts me at, here is 1 whole, here is 1/8, 2/8, 3/8, 4/8. So this would be 8/8, 9/8, 10/8, 11/8. So this is 12/8. So now I've got 6/8 plus 6/8 equals 12/8, which would be the same thing as 8/8 and 4/8. So it equals 1 4/8. All right, so let's try F. All right, so I'm going to start by estimating. So 6/5 is already greater than 1 whole. So I know that this is going to have to be greater than 1. So I'm going to go ahead and make this from 0 to 2. And then here's my 1 whole. So this time I'm going to get smart. I'm going to divide my fifths in red this time. So let's draw 4 lines. 1, 2, 3, 4. 1, 2, 3, 4. So here's my fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here is 6/5. All right. Now I'm going to take these and I'm going to divide these into tenths by dividing each of these fifths in half, just like this. So now instead of 5 parts, I have 10 parts. All right, so I'm going to start by adding 4 tenths. 1, 2, 3, 4. So here's 4 tenths. And then I have to add 6/5. All right, so how many tenths are there in 6/5? There are 12, so I have to count over 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to end up right here. Plus 6/5. So my new number sentence is 4 tenths plus 12 tenths equals 16 tenths. Well, 16 tenths is the same thing as 10 tenths and 6 tenths. So that is 1 6 tenths. So I don't know about you, but I'm finding the number line strategy to be just a little bit more confusing than the tape diagram strategy. So if you had a little bit of trouble with these last few problems, don't feel bad. That's why I didn't really suggest that you do any of these by yourself, because I felt like it was a little bit more complicated. All right, let's take a look at the very last problem. Solve the following addition problem without drawing a model. Show your work. So let's think about this for a minute. We do not have common units, but I did learn something whenever I was making those number lines. I learned something about whenever I was trying to take thirds and decompose them into sixes. What was I doing to the numerator and the denominator? Let's think about this for a minute, because we've used multiplication before. If I have 2 thirds and I want to make them into sixes, what do I multiply the numerator and the denominator by? I have to multiply them by 2. So now I have 4 sixes. So instead of 2 thirds plus 4 sixes, I can say 4 sixes plus 4 sixes equals 8 sixes, which is the same thing as 6 6 and 2 6, which is equal to 1 2 sixes. Okay, again, I know the number line strategy was pretty complicated. I actually think that this is probably the easiest strategy to use. Okay, and this is the strategy that's most efficient and that we will work towards. All right, good luck on your exit slip today.